Hello students, today we are going to start a lecture series on electronic circuits, or we can say electronic devices and circuits, or electronic circuit analysis. As the name suggests, it is electronic circuits. Okay, the major components used in these circuits are semiconductor devices, semiconductor components like transistor, MOSFET, operational amplifiers, voltage regulator ICs, and so on. This is the analog electronics or analog signal processing. Why this subject is there in the second year of engineering? We know that the physical parameters around us, they are analog in nature and it need to be converted. For example, if you think about a robot is fitted with different sensors to sense distance, to sense velocity, to sense speed, to sense temperature. There are so many physical parameters are need to be sensed and need to be converted into electrical signal. So these physical parameters, they are analog in nature and they will be in analog in nature. Therefore, we always require the front end of any sophisticated digital circuit is analog. We need these analog devices. Nobody is going to replace these analog circuits, analog devices. We need to process the signals, we need to amplify weak signals, we need to remove the noise. Therefore, this is the evergreen branch of study. So what this electronic circuit syllabus consists? The first chapter, first unit in electronic circuits is dedicated for MOSFET and DC analysis. Second chapter is also dedicated for the study of DC circuits using MOSFET. So these two units are in the syllabus and we can understand the how ICs are manufactured, what are the basics behind the design of or fabrication of integrated circuits. Because MOSFET is much useful for IC fabrication as compared to BJT, where BJT is more useful in discrete applications. Discrete circuits are made using BJTs and BJT is not preferred to make integrated circuit. Okay, why it is not preferred, we'll see later. In the first chapter, we have enhancement MOSFET. We are focusing more on enhancement MOSFET and we are not going to study the depletion MOSFET. Its construction, characteristics, DC load line, AC equivalent circuit. Okay, all these parameters are basic parameters. It is called DC analysis study of MOSFET. Finite output resistance, body effect, and subthreshold conduction. Okay, so it matters a lot in the fabrication of IC technology. Breakdown effects, temperature effect, and width to length ratio. Okay, this is about the channel present in the MOSFET, common source amplifier. Okay, so here from here it is the application of this MOSFET. This device is used here. Okay, so there are two parts in the first unit. One is the DC analysis and second is its application as an amplifier or common source amplifier and its analysis. Source follower circuit and comparison of these two things, and again the frequency response of amplifier. So what are the challenges in fabrication of IC, analog circuits or say digital circuits? So analog circuit designs or analog circuit design challenges. The first thing in the design is the transistor imperfections. The transistors are mounted on a thin wafer of silicon. Okay, and these transistors are scaled, they are very small in size. Okay, they are seen under microscope and they are integrated to make circuits. So the characteristic of transistor depends on its surroundings. Okay, so this is the important factor in the design technology adopted, such as size, shape, and its distance from other components around it. Okay, billions of transistors are created, we can say, or fabricated on a single thin silicon wafer under microscope, and what is the distance from each other of a transistor will decide the characteristic. Okay, there are some parasitic effects occur when two components are close to each other, or what should be the minimum distance it is designed, and what is the size of transistor. Okay, the size is, today the size of transistor is micro level, and it is called microelectronics, and these imperfections will lead the transistor characteristics. Now, declining supply voltages. If you see the era of 1970, you'll find that, so 18 volt, 12 volt, 18 volt, 30 volt DC voltage was required to operate the electronic circuits. As you know that electronic circuit require DC voltage to turn on it, because we can make the movement of holes and electrons by using the DC. Just like mechanical device require some energy, like okay, two-wheeler requires petrol as a driving force. So same way we require DC voltage. So these DC voltage were used of large amount. Now today even CMOS IC require 0.9 volt. Okay, our motherboard require plus 5 volt of DC voltage for its operation. We can go further to this, and many circuit designs are discarded, those not survived. Okay, the circuit designs those require higher DC voltages, they didn't sustain in the market. Because of that, the circuit designs discarded. Okay, so it is the power consumption. The semiconductor industry is striving for low power designs. As we said in this point, low power designs are preferred everywhere in the design of cell phones, sophisticated digital circuits, electronic gadgets. Okay, and why this power consumption is reduced drastically? Because of scaling of the device. Okay, the device is scaled. Scale means it is made smaller and smaller. It is being scaled means what? Suppose when we scale a dimension 1 multiplied by 0.1, okay, so it gets 0.1. So 1 meter into 0.1. So 0.1 here is a scaling factor. So the device channel length and its channel width is scaled in a particular fabrication technology. According to the scaling factor, the fabrication technology is categorized. So these are the challenges in the design of integrated circuits. Now see, if you see the first generation transistor, BJT, bipolar junction transistor. Let us have a brief look at the BJT concepts so that we can understand the MOSFET, the major differences. I am going to make separate videos on bipolar junction transistor and its theoretical details and its analysis, DC analysis and applications. So in short, I am going to tell about the bipolar. It is a bipolar device. Okay, what is the speciality of bipolar? Bipolar device, okay, is flows, the current in the device flows due to recombination of holes and electrons. So this is the speciality of bipolar. Means current is one, but it is carried due to the flow of electrons and flow of holes. Okay, so altogether it is the recombination occurs in the device. Without that, current is not possible in bipolar junction. It has two junctions. Okay, so here, so it is NPN transistor, and here there is a one junction J1, and here it is J2. So this region is the emitter region, this region is the base region, and this region is collector region. Okay, there are some difference between the physical structure of this one, emitter, base and collector. Obviously the base is very small and collector is larger area. It contains number of electrons, and emitter is heavily doped as compared to these two regions as compared to collector, and one junction is forward biased. Always it is the condition. One junction is forward biased. Here see, plus is applied here and minus is applied here. So this junction is forward biased and this junction is reverse biased. So this is one condition in BJT. We have to make a flow of electrons. We have to move the holes and electrons across the junction. For that we require this DC voltage. So it is the VCE voltage and this one is VBE voltage. So voltage across base and emitter. So the current will flow. Now one important thing, what is the relation between input node and output node? What are the quantities which controls the output current here? So this collector current, okay, it is flowing from this positive terminal plus, okay, so it is, we can show in the symbol, it is a symbol of BJT, and here the current flows like this IC and IE is grounded and it is the IB. So IB, so this current flows when we maintain the voltage, base emitter voltage here, but it is the current, actual current goes into the device. The base current, suppose base current is 0, what will be the collector current? So that is our point of discussion. Here if IB is 0, if I say IB is 0, so IC will also be 0. So it is the collector current and this is the collector to emitter voltage. So we are talking about the DC voltage and DC current. When IB is 0, so IC is 0. So this is the off state of the device. So it is called cutoff state of the transistor. Fine. So what is the relation between IB and IC? So it is given by, so collector current IC is beta times IB. So beta is what? Ratio of IC and IB. So if IB is 0, in this case what will be IC? So IC will also be 0, means IB decides the IC. When I increase the base current, I will get beta times IB. Here this is IB is suppose 100 microampere and I will get some IC here, so it is 2 milliampere. See, so base current will decide the collector current. We can say that BJT is current control device. BJT is current controlled device. Because current at input node controls the output current. Now what is the input resistance? Input resistance is low, okay. How come it is low? If I say Ri is DC input resistance, so DC input resistance is given by, so it is input side DC voltage divided by DC current. Suppose it is 0.7 volt, it requires 0.7 volt to turn on the device if it is silicon device, and if I consider it is 100 microampere base current, so it will be around 0.7, so it is 100 10 power minus 6, so it will be around 0.7, so it is plus 2 minus 6, it will be 10 raised to 4, so it is around 7 kilo ohm. So it is around 7 kilo ohm. So input resistance, DC input resistance of BJT is around 7 kilo ohm, okay. When you compare this point with MOSFET, we are going to study each and everything about the MOSFET, and there we will come to know that the input resistance of the device is much higher as compared to BJT. We require high input resistance in the design of amplifiers, design of flip-flops or digital circuits. So input resistance should be high, output resistance should be low. And here the comparison of MOSFET and BJT, the MOSFET has very much high input resistance as compared to BJT because their input current is negligibly 0 or ideally it is 0. Now see, Other important point to compare about BJT. BJT need more space as it is bipolar device. It require more space. So not useful in IC fabrication. Okay. So this is important point here. So IC fabrication technology, okay, requires such a device which will occupy less space on silicon wafer at the time of fabrication. So it has junction capacitance. Okay. So BJT has junctions. So this is the structure, and say this. So it is collector region. This is collector, base, and emitter. So it is N, P, N. Okay. So these are the junctions here. So depletion regions are present here. Opposite polarities. Here electrons and here holes. So these junction capacitance becomes predominant at high frequencies. So these are the junctions, and because of this junction there is a formation of capacitance, and one more capacitance is present there, that is called interelectrode capacitance. It is a BJT symbol, collector, emitter, and base. So between this base and collector there is one capacitance formation. In terminals, external leads, formation of capacitance. So these capacitance are called interelectrode capacitance. Okay, electrodes means terminals, and because of this interelectrode capacitance at high frequency, see, at high frequency they get shorted. Okay, because high frequency the capacitor allows the frequency. Okay, it bypasses the frequency. Suppose here we are getting some output. So here it's a very high frequency output we are getting. So this output will be shorted to ground, and what will be the output here? Will get 0 here. So bipolar junction transistor is made to operate at low frequencies. Okay, these capacitances are predominant at high frequencies, so not useful at high frequencies. This device BJT is useful for low frequency applications. Okay, and its switching speed is low. Why its switching speed is low? Because see, as it is a bipolar device, so these are the electrons, holes, and electrons. Okay, when we reverse, uh, when it is used in application, AC is applied. At that time, when we apply the AC signal and we change polarity, okay, suddenly there is a reversal of voltage across these terminals. These charge carriers require some settlement time. Okay, so it is called reverse recovery time. Reverse recovery time is more in case of BJT because of its bipolar, and this leads, okay, its switching speed, or it controls the switching speed. Because of this, switching speed is less. Okay, so it is not suitable to make high speed digital circuits. So these are some important points of bipolar junction transistor. Let us see about the MOSFET. So I have written MOS transistor because number of uh, MOS transistors are there. So in general we are talking about the MOS family. So what are the features of MOS family? The first important point is unipolar device. It is a unipolar device. It means the current flows due to flow of electrons or holes. It should be holes here. So current flows due to holes or due to electrons. Okay, not recombination. No recombination present in MOS transistors, metal oxide semiconductor transistors. It needs small space for fabrication of single transistor. Therefore, it is much useful in fabricating ICs. Okay, and the third important point about the MOS transistors or MOSFETs. Now, see, one device can be used different way. See, in ICs, in IC manufacturing, no external resistors are used. See, resistors are needed to design the circuit, to bias, to maintain different voltages. We need resistors. Without this, we cannot design. We need capacitors to produce some frequency responses, grounding purposes. Okay, capacitors. So here, same device is used as an amplifier because basically it is amplifier, high speed electronic switch, so that we can design digital circuits like memory circuits are designed by using this MOSFET. The same device is used as a voltage controlled resistor. So it is voltage controlled resistor, and separate resistor is not used. The same device is used as a resistor for controlling some biasing voltage, and the same device is used as a capacitor. Okay, so see, the features are more with MOSFET, and input resistance is very high because ideally its gate current is almost zero. Therefore, it is also called as insulated gate field effect transistor, and because of this it has a high input resistance. It is suitable to design the circuits, amplifiers, and so on. So in next lecture we are going to study about the MOS construction and various physical dimensions of MOS transistor.